Hello, this is John Sullivan. Sorry I'm missing my normal wonderful introductions. Hopefully the Arizona Computer Guru is going to get me a really cool computer sometime really soon, and we can work on that. I'm not really ready for my guitar yet, but I'm well enough to show you a series I will just simply call Meaningless Trivia. Right out of my head, but it's all true. Now let's pretend once again, like we did a couple years ago, that this is the Earth, that's the sun, and this is probably the moon about that far away. Now the Earth is actually spinning this way toward the east, as we all know, and actually the moon is actually going the same way, but because the Earth is spinning much faster, about 28 times faster than the moon is moving around the center of the Earth, which actually is what a month is, what's happening is, from sky to sky, night to night, it looks like the moon is actually drifting toward the west, but remember, we're down here on the fixed spot on Earth looking at the moon as it's going slower than the Earth is turning, so that's why it appears to be drifting to the west. But we happen to know right now, if you bring it in about 11 times, you're going to get to where geosynchronous orbit is, and that's where the Earth will actually move as it spins, so you can maintain a sight over a certain fix. And this is really good if you're in a place where you want to watch satellite television, because from anywhere within that footprint they can beam something up to the satellite. At this altitude, the satellite will normally relay it on a offset frequency a certain megahertz lower, and it's all based on channelization and everything else. Basically it's just a dumb thing that does that, and on dish TV all over the footprint within the line of sight of this satellite, you're going to see good TV or bad TV, but you'll see TV. And this is all caused by the uplink station, New York or LA or wherever, up to a certain spot in space. And they actually have a lot of it on fiber now, which is very interesting. Basically that's how it works for most of your cable TV and all for all your dish. So you're going to see, wherever you are on the Earth, you're going to see a look angle pointing to a satellite. So normally if you're on the equator, it'll be straight up. If you're up here in Canada, it's going to be very inclined, and actually weather and atmospherics of a very thick atmosphere will kind of mess with your coverage. Okay, now let's go to the International Space Station. Most things out of Kennedy have a natural efficiency of a 28.5 degree launch. And the Hubble Space Telescope is actually at that altitude about 350 miles up over the Earth. And anytime you go away from that natural efficiency, you have to use more fuel and leave your rockets on longer to fight the gravity of the Earth, because you don't get that 970 mile an hour speed bonus you do from Kennedy Space Center going toward the 28.5 degree launch. If you're going to the 51.6 degree orbit where the space station is, you have to use a lot more fuel and take off kind of toward the northeast and basically go right up the coastline. Now what happens is, as you're watching the space station at night, as night happens is when, this is day and this is night, when you're on a certain spot of the Earth and you cross into night, you can start to see that space station as it's going over your point, normally right before sunrise over here or right after sunset over here. And it's going to be that wonderful bright light just going like this at 17,500 miles an hour. If you know where to look and when to look, you really can't miss it. It's beautiful, and we see it all the time down here in Sierra Vista. But once again, once you pass out of that at night, the space station is still going to be flying over your head, but because it is flying over your head behind the Earth, you can't see it because it's just too dark and they don't turn their lights on and everything. They just kind of hang out in the cupola and watch the wonderful stars and Earth underneath. And they've got a lot of great night photography now of cities and things like that. But basically, you can see, they can see you, but you can't see them. It's basically how that goes. I've heard it's been done where they've spotted it going, if the Earth is here and the moon is over here, kind of pretty lit up, and the station happens to cross between the two, you can actually see the silhouette of the station between the Earth and the moon. It's rare, but people know how and when to look for that, and they do. Now what happens is, because the Earth is actually at a 3 or so degree inclination as it's orbiting the sun. And if you're on the northern hemisphere, this would be winter, and over here would be summer, because that's when the sun is more overhead. Now there happens to be a point, because when the Earth is over here about in June, where the orbit of the space station will actually be almost parallel to the sun. And so what happens when this occurs, about normally in July, is it's all the time sunny there. You're going to see days and days and days of nothing but the space station flying over at night. And you can see it 3 or 4 times just based on if you can see it from where you are, because it's always going to be lit up and reflecting the sun's light. And so you can see it at 2 in the morning, 3:30 in the morning, 5 o'clock in the morning, sometimes even 6:30 or 7. And so that happens because it's orbiting 16 times a day. So about once every 90 minutes it's going over and over and over. And the Earth is spinning like this, and you're going to see it the first time around very far to the east, if that's where you are. And on the next orbit it's going to be a little bit to the west, and a little bit to the west, and finally you're going to see it on the western, if you can see it 4 times, which is actually, it's possible, but it's rare in most locations. Now if you live up there in England, where some of my Twitter friends do, then you can see this thing almost on every orbit anyway, because it's always, in the summertime, the sun is always within the earshot of where the station is that it's flying over. But this is one of the times where they call it the Beta Cutout, and it has to do with the beta angles and everything related to the sun and the station. And in that period, you're going to see a whole lot of halts and moving people and cargo to and from the station. It gets very, very hot on the sun side and very, very cold on the back side, and it's kind of doesn't give it a chance to cool off, so there are some issues there. And space station will come down probably within about 10 years or so. And people say that there is a zero gravity experience up there, but there's really not, because what's happening is the gravity of the Earth, the center of the Earth, is always pulling on the station. But it happens to be going at 17,500 miles an hour, just fast enough to offset that gravity. So if you're inside there, it is the experience of weightlessness. It's really not. And how they're going to bring the station down is they're just going to slow it down a couple hundred miles an hour. That will be enough for it to come into the Earth, and it's going to be very spectacular. I hope NASA has a lot of cameras on board, but the crew will be off, and the whole thing will probably be the biggest fire show ever. Maybe in about 10 years, we may get something back up, who knows. But we did learn in these, I think it's on its 100,000th orbit now from the first assembly. We've learned how to live up there for 6 months at a time, and even further with Scott Kelly and a couple other people. That would be U.S. Navy Captain Scott Kelly, who is related to Gabby Gifford's husband, Mark Kelly, who's here in Tucson, but right now over in California enjoying the Endeavor. Now, one thing about that is when it does come in, it's going to be very, very spectacular, but it's going to probably be over the Indian Ocean or the Pacific Ocean, so nobody can see it. But it's going to make a big mess, and a whole lot of parts are going to survive. But I think we're going to plan it better than we did Skylab, which really came down uncontrolled and just happened to hit Australia. And sorry about that, my friends in Australia. We still kind of sorry about that, but you know, you got to see a good show. And that's going to be very interesting what happens. What happens though is the sun's always pouring out radiation, cosmic radiation, ultraviolet, infrared, everything else. And most of that is actually trapped in the upper and mid parts of the atmosphere, and it doesn't really, you know, mess with us much down here because of something called the UV sunscreen that the atmosphere provides. Now, actually, if you get out there on a really sunny day when the sun's very bright, it'll actually pierce through all that, and you'll get your sunburn. Up there on the space station, we don't have that atmospheric protection, but there is something that's called the magnetic radiation sphere, which is actually called the Van Allen radiation belt, and that actually is caused by the Earth going through. And what happens is, once in a while, a solar storm will come out, and hit the Earth, and the radiation belt will actually wrap everything into a donut shape, and it'll come down on the poles. And I can see all sorts of really cool pictures from people on Twitter of what you see up there in the northern hemispheres or the southern hemispheres when that is happening. Now, that actually is above, that layer of protection is above where the station is, which would be about right here. But there have been craft like the Geminis that actually spend a whole lot of time hanging out in the radiation belt. And if you go out further than that, it's wide open for radiation. So the guys that went to the moon and back and stuff like that had to deal with much more severe radiation, with or without a storm heading this way, than the guys who are just on the space station. Now that's interesting because when you go to Mars, first of all you have to deal with that radiation. It's going to be a lot worse than the 3 days or so it takes on the normal launch to get to the moon. And actually, it's going to take a lot longer. They're experimenting with some ways to get there faster. But the problem is, once you get to Mars, well, they don't have that nice little radiation belt because Mars really doesn't have a magnetic atmosphere or magnetic influence the way that Earth does. And so that little donut of protection that happens around the Earth, the Van Allen radiation belt, I will get this out, is actually absent around Mars. So on the day side of Mars, it's wide open even there for all sorts of cosmic radiation that is not experienced on the Earth. Number one. Number two, the atmosphere is a lot thinner anyway, so the protection even of the atmosphere is a lot less. So that's something we're going to have to work with, is how to protect the astronauts in that environment, far and beyond what's happening on the space station. However, we've sent a whole lot of experiments up to mess with experiments with long duration exposure to what radiation is seen from the space station. And we're developing really cool, not we, but contractors and very smart people are developing very cool ways to deflect or defend against the radiation. So we'll see a lot more on that. Some of it has to do with gold and other materials that we know will screen that out, but you can still see through them. Like some of your Navy planes will have gold windows because of radiation that's caused by some pods on the plane that want to get into the cockpit. Or the box office, as some female pilots have reminded me it's called now. But that is actually what's going to be on those spacecraft, to and from Mars and on Mars. So it's a whole different environment. Mars is actually half the width of Earth, twice the size of the moon, and it's a very interesting place. It happens to orbit about the same speed as Earth, but the daylight's about the same, but it's going to be a very different environment. Much colder, but much more cosmic radiation. In my lifetime, I think we're going to be there with men, either from NASA internationally, or my best bet is one of these commercial guys is just going to get a really wild idea and just go. And who's going to stop him, really? It's very interesting times ahead for the space program. We've been asked very patiently to wait for the development of the SLS with NASA, and SpaceX is now doing a Falcon Heavy 9 they intend to send out to Mars in a couple of years. There will be successes, there will be failures, but that's what happens when you launch airplanes, ships, cars, and everything else. Win some, lose some, let's win them all. But they do intend to give it a very safe environment as much as they can. And do I want to go there? No. When they invent the transporter, and I don't have to go 6 G's up and 4 G's down, yeah, I'll do it then. Thanks for watching. We'll call this, once again, the Useless Trivia Part 1. Enjoy the space station at all times of night during June. By July, you'll start seeing a couple hours, and then half the night for them is going to be in the daylight, or in the nighttime. But when they're orbiting in that strange angle where the sun is going to be on them all the time, we'll see them a lot down here. So wave to Jeff and family and tell them hi. God bless.